All right, kiddos, as you come in, I am going to be working on this example from yesterday. All right, as you guys are coming in, I'm going to go ahead and this example, I was just going to copy and paste a solution from last year. I ended up thinking it might have been better for me, or it might be better for me to go ahead and just kind of show you guys this final example. So go ahead and as you come in, get out your notes. Open up to 7.6, the very end. I think this is where your blended homework came in yesterday, or not came in, where it ended yesterday was 7.5, 7.6. This should have been the last type of problem. So I'm going to go ahead and start solving it right away. The last thing I said yesterday was whenever you see x greater than or equal to 0 and y greater than or equal to 0, it means we get to just look in quadrant 1. We get to ignore everybody else. Remember in 7.6, you guys should not have seen any word problems last night. I took them all out. That's how we're making it the short and sweet version. Come on, Nehemiah. But I wanted to go ahead and kind of just show you, instead of just showing you a solution, show you step by step. So this kind of should relate to 7.5 though, because 7.5, weren't you supposed to graph systems of inequalities, right? So hopefully last night, sometimes, well, actually it might have looked a little bit even simpler than this last night. Come on in quickly. You should have been getting y by itself. So to get y by itself in this one, I would have gotten y, or I should say 2y, less than or equal to, we would have had to subtract x to the other side. Then we would have had to divide everybody by 2. So y is less than or equal to negative 1/2 x plus 2. That's going to be 1 that I'm going to graph. Remember, these two have already been checked off just by me only looking in quadrant 1. So those are good. I'm looking in quadrant 1 alone. I'm going to have to get this green guy in. Let's go get the green guy in. Remember, mx plus b, we use b first. So I'm going to go ahead and go up to. Let me get some tick marks on here. I'm going to have a y-intercept at 2, if I can get him. I'm going to go down 1 and over 2, down 1 and over 2. Now guys, why am I connecting this with a solid line? Good. It's greater than or equal to. I'm not going beyond the first quadrant, because remember, it doesn't matter anywhere beyond for conditions 1 and 2 to be true. Now, am I going to shade below that or above that? If this is my downhill, am I going on underground or am I going to the sky? What does my inequality tell me? Yeah. Hold on. Is this a less than or a greater than? Less than. Okay. All right. We need, yes, or equal to, but I already did the solid line, so the or equal to is done. Less than, am I shading below or above? Below. Okay, we were supposed to do 7.5 last night. This is so far just 7.5. So, below. But am I done? No. But I have condition 1 and 2, just looking in the first quadrant. I have condition 3. I only have one more left. Okay, let's focus. So I graphed a line. I did a shading check. I have one more. Graph a line, do a shading. How would you guys go about getting y by itself in this one? Subtract the x? Okay. So subtracting the x, I need to make sure that I leave the negative with the y. Subtracting the x moves them to the other side. I'm going to have to divide or multiply by the negative and switch the inequality, because all of those need to happen. Because when you multiply or divide by a negative to everybody, the inequality always flips. So y is greater than or equal to, a negative over a negative is a positive, positive over negative is a negative. Now I need to graph him. However, his intercept is at a -1. Well, I still need to put it because that's like the foundation of who this guy is, but I'm not going to actually put his line because I need to get up into the first quadrant. So hopefully that happens pretty quickly. Oh, okay. What's my slope? Up 1 over 1. Oh, there we go. And then up 1 over 1. There we go. And then up 1 over 1. I can keep going a little bit further. Up 1 over 1. Okay. Dashed or solid? Solid. I'm not going to really matter about that guy, though, because I'm only looking in the first quadrant. So let's just go here. I can keep going forever. Oops, I don't need that extra line. Question, though. Shading below or shading above? Above. Because it says greater than or equal to. So staying in the first quadrant, going above. Do you guys see my overlap? Yes. Right there. True? Now, I'm going to go ahead and just take a second and zoom in on that overlap. I actually have the book's version of that overlap on the next page. But any questions about how I got that overlap? Oh, go ahead. Yeah. Uh-huh. No, it would be okay, except you would need to know from these two. I have a string. You would need to know from these two that even though this would go on forever that way and this would go on forever that way, that these two say, but I only want this little piece. Because you also need that guy and you also need that guy. And so this only really shows up, Lauren, I don't think this showed up 7, 5, did it? I think only 7, 6. So 4, 7, 6, you're going to see these two, and I'm just telling you, whenever you see those two, just say, I'm only looking in quadrant 1. So I would technically, if you see these two, I would only draw quadrant 1. That's like an easier way of doing it. Yeah. So zooming in on that, unless the computer decides to not do what I tell it to. Okay. Do you guys see how this is that same little region? Yeah. Just without all the lines and all the shading? What do you notice they've also figured out? Points. All the points, all the, what's the nice term? Vertices. Vertices. But Jason, what you said is important because I need to test the vertices to find, what did they actually want me to do in this problem? Let's see what they actually, oh, just the max. But sometimes it'll be the min. So I need to go ahead and basically finish off this problem doing what we saw yesterday, which was find the overlap, take the vertices, and check who's the highest. How do I check? Well, this is the testing step. Let's take all the vertices. So I have 1 corner, 2 corners, 3 corners, 4 corners. I'm going to go ahead and take each of those vertices, and I'm going to plug each of them into my objective. Ooh, does anybody have that? Was that 2x plus, no, 3x. Thank you. And all we need to do is find who's the max. So take each point, and it doesn't really need to be in any order. You're going to have to try all of them anyway to find the biggest one. Or, Jason, if it was asking min, you'd find the smallest one. So if you plug and chug, z equals 3 times 0 plus 2 times 2. 0 plus 4 is when you plug in the x and the y. And then z in this one, well, 3 times 0 plus 2 times 0. 0 plus 0 is 0. This one, plugging in the 1 and the 0 gets me 3 plus 0. And this one, plugging in the 2, 2 times 3 is 6, plus 1 times 2 is 2. Joe's already saying it's 8 and 9. So who's my, well, hold on. Be careful that you know how to answer this. What is the maximum that z can get? 8. It's a max of 8 at 2, 1. Dun, 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 dun. Why did I say it that way? Because what if they ask what is the maximum, the highest it can get? 8. When does that happen? Oh, at 2, 1. Does that make sense? Now, wait. What do you think was the hardest part of this problem? The last page or this page? I think so too. So, just throwing something out there. You guys all listening carefully? You all listening carefully? If this last page was the hardest part, what if there's a problem on the test? I'm not saying it's the only type from 7-6, but what if there's a problem on the test that already has the picture drawn? What could you do? Just this part, and you're done, right? So if the picture's already drawn, she's alive. If the picture's already drawn, can you just use it? Yeah. If the picture's already drawn, just use it and find me the max or the min, whatever you're looking for. Now, if the picture's not drawn, and you're given something like this, don't you have to draw the picture first and then find the max or min? Okay. Joe.
The picture was drawn, but they gave you an equation but without points on the picture.
Well, that'd be a kind of lame picture. So maybe I should say, what if the picture is drawn with the point shown? Lauren. If it shows the points, you don't actually need the equations. My guess is it would probably give both, but I'm just saying if you see the equations, oh, it's going to have to give you, I see. It wouldn't just give you a picture. If this is what's necessary, it would also have the question as well. So it would have all of this, but what if it already had, what if it had all of that, but it already had that drawn? Would you have to do it again? No, just use it. Does that make sense? Yeah. But if the picture wasn't drawn, then you just need to go ahead and start with your own picture, get your own corners, and then plug in. Just showing you the difference. If the picture's there, don't go doing, every now and then kids see a picture and they're like, they don't realize and they have to do their own and they're like, oh my goodness, it was the same. I just wasted all that time. So that's why I wanted to let you guys know. If there's already a picture there, use it. Use it. If there is no picture, you have to get one. Kiddos, to that end, I think that's pretty much the end of our 7-5, 7-6 blended. Let's go grade. Now, in Google Classroom, I have it up here so we can reference. I posted a comment that should have sent you an email. Sadly, I had to sub during one prep period, and I got called away during the other prep period for a couple things, and then I got stuck after school. So it didn't get updated as early as I would have liked, but this was the final homework. Some of you might have done a little bit more of 7-5 than you needed. All that means, besides you getting a little extra practice, whatever I took out of 7-5, I think I took out like a businessy problem having to do with, what was it, supply and demand or something, I think? Yeah, I took that out because supply and demand isn't on the test. And then I took out like a few review problems from the beginning of chapter 7 because I'm like, well, we're doing the test review next anyway, so it's not a big deal. So I took away a little bit from 7-5. I took away the businessy one, the supply demand, and then some of the review. And I just added in a few from 7-6, but I didn't get to the word problems. Let's go ahead. My evens might be a little bit off to that end. Oh, hey, I only gave you odds in 7-6. So you could check and come with questions. So let's go grade the evens on 7-5. Just add it in and then post a comment and be like, I did it before. Does that make sense? And I'll excuse it. Is that cool? But you still want to do them because, good. Yeah, Joe, I saw that you had already submitted yours. So that's fine. I thought we were good. Yeah. So if anybody submitted it early and you didn't see the 7-6 problems added in, just go ahead and add in 7-6 tonight, post a comment and be like, I did it early, please excuse. And I will. Okay, 7-5, here we go. Number 14, did you guys put a solid line and shade above the hill? Solid shade above. Number 26, you were allowed to use your graphing calculator? Parabola, there he is, and did you shade below the parabola, below the boundary? Number 44, now this is the overlap, guys, so you should have had, or you could have had more shading than this. You were going above the line and below the circle. The overlap would have been this little part right here. And the intersections, which you could have done with your calculator or solving the system using like 7-1, 7-2 techniques, ended up being positive 3, 4 and negative 3, negative 4. So you could have used some algebra. That's what I would have done because I wouldn't have wanted to use my calculator. That's what they did too. They used some substitution, I think. But shading above the line, below the circle, there's the overlap. The vertices are these two guys. Number 54. Oh, you did have an x greater than or equal to 0. Did you guys see it was the first quadrant? You might not have thought about that. If we go look at the, I think I have it right here in my 54. He's over here. Did they give you a picture? Yeah. In number 54, it was only the first quadrant. So that's why they had the x greater than 0, y greater than 0, because it didn't go out of the first quadrant. So maybe you figured out, now some of you might have struggled, but you were making equations of lines. How many of you guys had a question on 54 coming in today? A few, yeah. I just need you to be brave, because almost every year kids don't like this one, so I figured I could go over it real fast. Aren't you just plugging into y equals mx plus b? And then adding inequalities? So for this guy right here, doesn't he hit at 4? And he goes down 4 over 4, which would be down 1 over 1, down 1 over 1, down 1 over. He goes down 4 over 4. So he's going to be y equals, his b is 4, and his slope is negative 4 over 4, which is negative 1. So he's y is greater than or equal to, because the shading is up and it's solid, negative x plus 4. That's that guy. And then the next guy, well, that must be 2, right? If we're going by 2s? Yeah, that's right, Joe. It hits at 2. So then if I'm trying to make my mx plus b, 2 is my b, and this one goes down to over 8. So this one was 4 over 4, which is how I got negative 1. This one is down to over 8, and some of you have already said that's negative 1/4. Isn't the shading also above that guy? So y is greater than or equal to negative 1/4 x plus 2. And then as we already said, to only look at the first quadrant has my x greater than or equal to 0. So I guess, Lauren, it showed up just once in homework 7-5. And let's go double check, but I'm pretty sure. Yeah. Now, they wrote it weird. I wouldn't have written it that way. They wrote it this way because they like the minus on the other end, but it's okay to have negative x plus 4 and negative 1/4 x plus 2. Joe? Well, all lines always go into the fourth quadrant, but it was cut into the first quadrant anyway, so that's why they didn't show that quadrant.
I mean, if the line keeps going, they have two options. One is it going to the
no.
fourth quadrant, one is it doesn't. Like the chart is
I'm going back, Joe. Right here. I see what you're saying. You're saying like this one could have kept going, so it's hard to see. But I could see this one is x greater than or equal to 0. And then this one, if it was shared, what Joe is saying is, well, it could have been just above that line and not above that line. I know it was kind of hard to see, but they were trying to show you clearly it was only in the first quadrant. So Joe, a better question would have gone a little bit more and shown a little bit more of a tail. I understand. There won't be one as tricky as that tomorrow on the test. But first quadrant, they were intending to show you. Lauren, go ahead. Yeah. Not the entire calculator portion, because you won't have just this type of problem. But that could be an example of when the calculator could be useful. What Lauren's talking about is down here, 47. These ones, the intersections were a lot nastier. So yeah, there could be ones with kind of nasty solutions or kind of nasty intersections where I would want you to use the calculator. But I'll give you hints about what's on the calculator portion versus the non-calculator in just a second. And then you can kind of like write down as far as whether or not this type of problem will even be on there. Any questions on evens or odds of homework? Yeah. Yeah, and that's 7-5, right? Sam? Okay. 44 is right up here. He's kind of nasty because he's a circle. As I get him ready, do you guys have any other questions on 7-5 or 7-6? Okay. And that's 7-5 also, Lauren, right? Okay. For those of you guys that might or might not need these questions, if you don't need them, let me go ahead and quickly get no evens on 7-6. You can take a quick picture of the test review if you haven't already written it down from Google Classroom. If you want to come up and borrow a book, you definitely can. I'm going to go over questions. Feel free to listen. I'll get all of your attention before I give any other hints on the test. But if you do want to get started on the test review, books are up here. Come grab them in the next 30 seconds. Yeah, go ahead. Go ahead. If you want a book, come grab it real quick. That way, as I'm answering questions, you guys can be productive. But then we're going to go over 44. And then back to 15. Right, Lauren? Okay. So number 44 first. Anybody else need a picture of the test review? Okay. Number 44. Let me get rid of, I don't know why Firefox opened. That was my bad. Okay, I think we were just graphing, Sam, and trying to find the vertices of the region. This one's a little bit harder. It's not technically, or it wouldn't technically be like a calculator problem, because this fits my standard form of a circle equation, where the circle is centered at 0, 0, and goes over 5, up 5, left 5, and down 5. This one's a little tricky because less than for a circle is kind of nasty, because you're thinking below, but then there's below, but then the below is kind of like also above. And so this might be a good example where we do that whole testing of the point idea as far as here. So if I was to test in this the point 0, 0, I would plug in as my point, and basically I'm just asking myself the question, true or false. So since 0 is less than or equal to 25, since it's true, wherever that point is gets shaded. So I'm going to go ahead and shade. So the less than or equal to meant solid, less than, in this case, because 0, 0 was true, meant in shaded, not outside. Then I go ahead and I transition to my other point. I should say my other constraint. But I can't graph it like that. That's standard form. So I'm going to get y by itself by subtracting 4x to the other side, dividing by -3. Oh, I guess 0 just goes away. But when I divide any inequality, I have to switch the sign. A negative over a negative is a positive. You could think about plus 0 if that helps, because the intercept is 0. So I start at the point 0, 0. And then I'm going to go up 4 over 3. And you can check it, but when you go up 4 over 3, it actually seems to hit the circle. We're going to go down 4, left 3, which should also seem to hit the circle, like if you were keeping it kind of nice in your measurements. And so you could already kind of just be guessing. I think it's 4, 3. Oh, sorry, up 4 over 3. Remember, ordered pairs, the x goes first. So that would be an x of 3, a y of 4. And then an x of -3, a y of -4. But we could also double check that. Sorry, the shading needs to be greater than or equal to. Or equal to means a solid line. Greater than means above. And then the overlap was this kind of little portion of the circle right here. But then the other way of getting the two vertices, the 3, 4, and the -3, -4, could have been, and guys, this is good review for the test tomorrow, could have been going back to the beginning of chapter 7, where we might have had to solve this system. So if we had something like x squared plus y squared, it's trying to find the points where the equals would be, trying to find a solution to the system if it was an equals. That's what these little vertices are, intersections. I guess we don't even have to think about that. We can just think about equals. The sad thing is there's not a great. I think I would have probably done substitution because I can't make those match for elimination. And so substitution, I could have gotten x is equal to, add the 3y, divide by 4. I could have plugged and chugged. And so plugging in, I would have had 3y over 4 squared plus y squared is equal to 25. I'm going to go ahead and erase this work. If I can get it all. Can I get it all? There we go. 9y squared over 16 plus, I could actually do a common denominator guy, I suppose, to make my life a little easier. That would be 25y squared multiplied both sides of 16. $25, 16 quarters would be 400. Dividing both by 25. I guess the 25s would cancel if I divided. Either way, you would eventually get to where the y's need to be plus or minus 4. And then once you have the y's, you could go back and you could plug in and get the x's. Because a plus or minus 4 would make 16. When I subtract, I get 9, and x would be plus or minus 3. You kind of get there eventually, but this one, I think graphing, I think they were indicating graphing was the easiest way, sadly. If it's true, you shade where the point is. If it's false, you shade in the part that it's not. So since 0, 0 was on the inside, true meant inside. If 0, 0 had been false, you would have shaded everywhere 0, 0 wasn't. Yeah. Lauren. The only reason I would say shade the whole thing is because if you have, like instead of 2, if you have 3 or 4, trying to keep track of where everybody is hard. So it can be easier just to kind of be like, okay, this guy, it's all of this. This guy, it's all of that. This guy. And that's why I say different colors. And then you say, okay, now put it all together. Because if it's only 2, you can kind of keep track of, like, okay, below and above. But if it's 3 or 4, it starts to get a little messy. Like, hard to keep track. In 7-5. Yeah. Okay, but you all said number 15. Oh, he was just nasty. And Sam, I guess this one's kind of like your question, like the part that you got stuck on. Because number 15 says, hey, he's a circle. But this is a different circle in that this circle has an H and has a K. So its HK, or its center, would be x minus H, negative 1, y minus K, 2. And then its R is equal to the square root 3. So I would have gone negative 1, positive 2, and I would have had to go 3 over 1, 3 over 3 up, 3 down. I'm going solid, but what do you guys see with the inequality? Shouldn't it be dotted?
Yes.
Okay. So how do I test? Nice thing is, I think 0, 0 is still not on the boundary, so I'm allowed to use him just because he's easy. So I would have tested 0, 0. Remember, if it's true, I'm shading where he is on the inside. And if he's false, I'm shading where he's not on the outside. So plugging in 0 here, 0 plus 1 is 1. 0 minus 2 is negative 2, but negative 2 squared is going to be a positive. Is that less than 9? True. So therefore. Is that good, Lauren? Yeah. Circle ones, it's hard, the above or the below. But if you remember the standard form of a circle equation, the center is shown by what's added or subtracted, like this one, or what's not, because 0, 0 was the other one. Well, this one, I did 3 for all of them, but it had to go from this center point. So I went 3 and 3 and 3 and 3. The other one, it was centered at 0, 0, so I went 5 and 5 and 5. Because every circle is equidistant. So I went 3 all the way around for this guy, and then the last example, from 0, 0, I went 5 all the way around. Yeah. Yeah. Okay, last call on section 7576, blended questions. Okay, I'm going to grab all of your guys' attention because I'm going to go ahead and give some hints for tomorrow's test. Sound good? So whether you want to be putting these hints on the test review itself, so you can be thinking about them as you're working through it, or whether you would rather have this at like the end of your notes in a different color pen, that's totally fine as well. But I've already mentioned there is a non-calculator and calculator portion to tomorrow's test. After you guys turn in tomorrow's test, I am going to I am going to give you back your Chapter 6 test to start working on corrections. You guys know that wasn't put in for the end of the grading period because you hadn't gotten a chance to do corrections yet. They won't be due on Monday, but it will be kind of like your weekend's homework due next week. Jason?
Oh, I have a question.
Oh, not right now, but I'm giving hints on the test, yeah? So you will be getting back your Chapter 6 test after the test tomorrow, but for right now, let's just get to Chapter 7. So tomorrow's test, 2 portions. Non-calculator comes first. Your calculator starts open under your desk. Wait a minute, what do you do when you walk in tomorrow? Let's get in the zone. First things first. Phone in the chart. What group are you? Matthew, Nehemiah, what group? 1. Sam, Tyler, and Ariman, you're 2. You guys are 3. Back in the back, you're 4, then 5, then 6. Last time we were a little confused as to what group we were. So get your phones in the chart. Now what? What comes up to the front table? Notes and homework spiral. What do you need updated in your notes? Table of contents, and a lot of you guys have been absent. So have you made up your notes from when you've been gone? They're online. They're in the YouTube videos. You can ask a friend so many ways. Notes need to be updated. Table of contents, page numbers. Don't get anything less than 100. Homework spirals. How do you get 100%? Completing the homework. If you had questions in Google Classroom, they should have been answered in class or after school. So it needs to be completed, but also graded, right? So make sure, wait, I was absent on the day that we were grading. Yes, but what do I record every day when we do it? The grading. Now, sometimes there isn't sound. Yesterday, something happened with the mic. However, you should still be able to see the evens in the videos. Does that make sense? My people that were absent especially? So homework attempted, finished, corrected. That will get you 100%. What if there are any Google Classroom assignments I've been missing because I've been absent? Submit them and post an absent comment. And when I go back and look through, as long as it matches up, it'll be excused. And then if you're like, oh, wait, I didn't submit some, but I finished it for the test, you can submit for late partial credit, and that's totally fine as well. Okay, sorry. So we have phones, we have homework spirals, we have notes. At your desk, you need a calculator for the calculator portion, but we're starting with the non-calculator portion. So here's the non-calculator portion. What are you going to see? You're going to have to do some substitution and some elimination. If it's a multiple choice answer and I tell you to use a method, will you get full credit by getting the right answer with no work? No. You'll get partial credit. Because some of you are like, I can just plug in the point and see if it works. But what did I just say? I'm going to tell you to use substitution or elimination, okay? Cool. Partial fractions. Do you remember in homework there were some partial fractions you didn't have to solve for? And then some partial fractions you did? Do you know what I'm talking about? A's and B's versus numbers. So maybe you should look at the multiple choice answers and see if they're A's and B's or numbers before you do all the work and you didn't have to. Does that make sense? So maybe you just have to show the form. And then something to do with an inequality. Calculator portion. Oh, wait, that's it? Substitution, elimination, partial fractions, maybe not even solving, and then graphing an inequality. Okay, so what's on the calculator part? What's on the calculator part? On the calculator part, something to do with a system of equations and a rectangle. I'm giving you a very specific hint because we did it in class and in homework, but yet kiddos always forget it. Something to do with a system applied to a rectangle. Row echelon form. Solving a system with row echelon form. Do you guys remember what section that was? 7.3. Remember how we had to take a system, put it into a matrix, and get all the way down to ones and zeros? Careful. I'm letting you do your calculator just in case adding and subtracting and multiplying you get confused. You can use your calculator for adding, subtracting, and multiplying. But to get full credit, you have to show me getting from the original matrix all the way down to the ones and zeros and answers, okay? Partial fraction decomposition all the way to the numbers. Section 7.5, a problem, like graphing inequalities and putting them all together, the overlap. Section 7.6, a problem. And then a big ol' improper partial fraction decomposition. And then a big ol' improper partial fraction decomposition. If we had gotten a little bit further in 7.6, there might have been another problem, so I'm actually going to have a problem totally crossed out on your test. Part of it is because of time, and part of it is because of how little we did in 7.6. Does that make sense? So there's only one 7.6 problem. 7.5, I think I kind of said there were two. There was one on the calculator, one on the non-calculator, one simpler, one harder. But what did I say about the big old problem at the very end of the test, which indicates the long answer? Improper partial fraction decomposition. All right, cool kids. So I think the ones that you should be most careful for in studying, that rectangle problem, the row echelon problem from 7.3, and then the improper partial fraction problem from 7.4. Do you guys have an idea of what to study? Cool. We have 10-ish minutes. So if I were you, start playing with the review. I'm totally up here. If someone gets to a question on the review they want me to answer, I will record the answer up here. Jason already has some. Sam has a question. Yeah, I'll open up the practice or the test review, Sam, and see if I can find a good one, because that'll help in both ways. Jason, what was your quick problem?
Mine was like really small.
Oh, go ahead.
So for
Oh, on your specific work?
it's really specific.
Let me just, if you're talking, try to keep it to a whisper. If it's okay, I'm going to go check the matrix, if that's okay, kiddo. Checking I wrote it right, or else things get really sad really fast. Okay. This is 7.3 row echelon form, which could also be Gaussian elimination. We always start working by columns. And each column we get the 1 first. So we want 1s to finally be, or eventually be, along this main diagonal. To get a 1, we always divide. So I'm going to do 1 over 2, or 1/2 times row 1, because dividing by 2 will get me my 1. What I do to 1, I have to do to them all. Is that good? So 2 divided by 2, 1. 0 divided by anything. 6 divided by 2. And 9 divided by 2. And I have my 1. What, Lauren? This is section 7.3, row echelon form. Okay. I mean, I'm in my notes. So here, we'll go back. Oh, sorry, guys. Sorry. Thanks, Lauren. I'm doing matrices in chapter. I apologize. Row echelon form is in both matrices and it's in chapter 8 and in chapter 7. And I'm doing chapter 8 with honors pre-calc tomorrow. So row echelon form. Sorry, Sam. You were like looking at me like, what? You were being a champ, though, because you were totally going along. We have two. I just saw Jason's, too. I should have remembered it was a system. Right? All better. Double checking I wrote it right, because once again, if I write it wrong, we're in trouble. Got it? Got it? Got it. Okay. We got it. Eliminate x's using R1, R2, and using R2, R3. Better, right, guys? I'm not going to be able to eliminate unless I multiply by something, right? So I'm going to multiply this guy by, and this guy by -2. Is that okay? Okay. So then I'll end up with, well, I'll just stay in black. 6x plus 18z equals -20. So I'm just distributing that to everybody. And then -6x plus 4y minus 22z equals 32. Good? The nice thing about making them opposite but matching is that will cancel out. The x's are gone. 0, if there's nothing there. 0y plus 4y is 4y. 18z minus 22z. You will have your calculators on this one, so if you need to, just to double check. But it would be -4z. And then -27 and 32 would be 5. You guys cool with that one? But that is only half of the eliminating x's. Now we have to go do another eliminating x's using these two. Oh, hey, these are basically ready to go, except all I need is a negative. So I'm going to keep that first guy. He was okay the way he was. But I'm going to just make a negative for everybody. So a -3x, a +y, a -7z, and a +11. That way my x's are gone. -2y plus y would be -y. 11 minus 7. And then -5. Looking good, yeah? So where does row echelon form go next? We eliminated x's. Now let's go ahead and eliminate y's. In some ways, but then you're going to go about a different system where you might get lost. So in my mind, I'm like, is it really that hard to multiply by 4? Huh. So it's technically, in some ways, up to you, but I really don't want to take off that extra point. And remember, if it's a computer program, the computer wouldn't recognize what's easier or not. It would just go with what it's been told. So that's another reason why I would say stick to the system. I'm going to multiply everybody by 4. But Jason, you're a creative mind. I'm not saying it's wrong. It's just some people would get thrown off by going a different way. I think technically, guys, I called this like row 4 and row 5, right? We were using these two. Multiply everybody by 4, so -4y plus 16z equals -20. My y's are gone. I have 12z equals -15. What, Lauren? Oh, we're right there. Because now we're going to go ahead and make our little row echelon form. So we can steal this guy, technically dividing everybody by 2. So that'd be 1x plus 3z equals negative 9 halves. Then we can steal one of these guys. I'll steal him because he already almost has a 1. But multiplying everybody by a negative, so y minus 4z equals positive 5. So I have my 1, I have my 1, I just need my 1z, which I'll get as soon as I divide by 12. 3 goes in 5 times and 4 times. Z equals negative 5/4. Now all I have to do to finish is back substitute. Now it is a little messy because there are fractions, but once again I said that you would be allowed to have your calculator on this problem. So you need to show me your steps, but you can be using your calculator for your facts, like your addition, subtraction, etc. So at this point, Lauren, do you see it? Now it's time to go plug and check. So, oh, actually this one's not bad because 4 times 5/4, aren't the 4's going to reduce? A negative times a negative is a positive. So add, I think y ends up being 10. That's what it looks like. A negative times a negative. Oh, it would be a positive. My bad. Then you would have to minus, right? That's what happens when you run out of room. Negative times negative is a positive. Subtracting, y equals 0. There we go. And then we would go plug in y equals 0 for, well, he's not even there. We'll forget that. And then z equals negative 5/4. That's going to take a little more work for my x. So to finish off your problem, you'd have to go ahead and plug in. There is no y spot, otherwise we would use it. Sadly, we can't reduce anything there. So we would have x minus 15/4 equals, I'm going to go ahead and get a common denominator because I see that 4th that needs to be coming. So that's going to be negative 18/4. If I add 15/4 to the other side, I believe that gets me negative 3/4. Has anybody finished that problem yet? To the point where you can match up? That's a good row echelon form one. I mean, it's nasty because there are fractions. I don't think I have one with fractions tomorrow, but it's the idea. So you take the first 2, get rid of x's. The second 2, get rid of x's, like with elimination. Take these guys. They'll always have y's and z's. Get rid of y's. And then you're ready for your z to go back into one of your yz's, and both of them to go back into your xyz. All right, guys, if you're ready, you can go. I'm just going to finish up with Sam's question, but finish up your review. Be ready for tomorrow. Technically, in the row echelon form, even though we could have just stolen an equation, stolen an equation, stolen an equation, row echelon form is like how computers work with matrices. It says to always get a 1 at the beginning. So since it wasn't a 1, I divided by 2. So I could have divided everything by 4 instead, but I just divided everything by a negative 1. Yeah. I think